Okay, well, hello everyone, and welcome to our deep dive on connecting conditions to relevant data. I think, Fizza, if you'd like to start us off.
Yeah, thanks so much, Chris. I want to thank everyone for attending. So Chris and I will be hosting today's session. My name is Fizza, and I'm the manager for expansion sales here at DrugBank. And I'll go ahead and let my colleague Chris introduce himself.
Thank you, Fizza. So hello again, everyone. My name is Chris. I'm currently the lead of the scientific support team here at DrugBank.
Great. So in the next 25 minutes or so, we're going to be talking a little bit around what we mean when we use the term conditions and why working with conditions data can be really challenging. We're going to talk about how DrugBank can help standardize and improve the ways that our users work with conditions data. And we're going to talk about our technology, so why DrugBank, how our technology works, what it is that we do exactly. We're also going to touch on the differences between a database and a knowledge base, which is something that comes up quite often. We're going to touch a little bit on how our licenses work. And then we do have some time for Q&A at the end as well. Please do feel free to add your questions to either the chat or there's a question function throughout the session as well. We will try and get to all of these, but depending on time, we may need to connect with some of the folks here after the fact just to follow up on your questions. So yeah, without further ado, Chris, I'll let you take it from here.
Okay, perfect. Thank you. Okay, so we're going to jump right in. So I'm going to talk a little bit about conditions and what we mean when we say term condition. So when we work in the biomedical space, whether it be in terms of research or patient care, we often need to refer to some notion of a physical characteristic or state. So this could be things like disease states, but also things like symptoms associated with diseases. And of course, these can be shared across multiple different diseases in terms of the way that they present. But there could also be other characteristics that don't fit under either of these umbrellas that might be nonetheless valuable to capture. And in DrugBank, all of these different kinds of things are captured together under the singular notion of a condition in our conditions dataset. So one of the problems with this kind of information is that it can be really difficult to capture it well and to capture it in a way that makes it usable. So of course, if we write something out, it's perfectly interpretable for humans, but it can be difficult to actually capture it in a way that makes it easy for machines to understand and to work with. So there's a lot of different reasons for this. The first is that there are a lot of ontologies that exist in this space that attempt to solve this problem, but each one has its own focus area and specific goals in mind. So for example, ICD-10 is really focused on epidemiology or reporting for disease or for medical treatment reimbursement for things like insurance. Whereas other things like the HPO is focused on symptoms and hereditary diseases, and so on and so forth. Another thing that's difficult is converting between these different ontologies in terms of equivalency. So which entries in different places should be considered equivalent. And even within the same ontology, you might have difficulty equating things that are actually synonymous. So you could write, for example, type 2 diabetes or diabetes mellitus type 2, and those are arguably the same condition, but they may be referred to as separate entries either within the same ontology or across different ontologies. And then, of course, each of these different ontologies has their own notion of hierarchy, which further complicates the picture, especially in cases where you can have multiple inheritance. So potentially the same condition may have different parents in different parts of the hierarchical structure of the ontology. And then finally, there's a lot of details that you may want to capture, but it's usually unclear whether those are actually part of the ontology or whether they just exist in some larger system that captures that information. So a really good example here is an idea like a fracture. So you can have a fracture in a certain part of your body, but is it to the level where the actual location is specified in that hierarchy, or is that just additional information that you need to capture on top of that? So this is a really tricky issue, and it's difficult to reliably work with this data. So what we've done is we've been building our own proprietary ontology of medical concepts, including diseases, symptoms, and anything else related to patients, sort of as we mentioned before. Now, this is partially based on a union of ICD-10, MEDRA, and SNOMED. And so, of course, we also include mappings for each of these external ontologies as a native part of the data set. But then we've really been building on top of these and expanding them out to get to quite a large set of conditions in a hierarchical structure. Now, as one might expect, these are arranged in such a structure for ease of use. And this allows you to not only get more specific for a general umbrella condition, but also to find commonality between multiple separate conditions and see, what's the most recent parent that shares all of them as children. So there's a lot of different ways that you can use this. And within DrugBank, we actually use this data set as a kind of glue that ties together a lot of our other data sets in some way, shape, or form. So really quickly, just for people who may not be familiar with the idea of what a hierarchy means, we have like a really simple example here. So we can see that there's heart failure, and then there's a more specific form of heart failure, which is acute heart failure. And there's even more specific form, which is an acute decompensated heart failure. And so here we would say that acute heart failure is both a child of its parent condition, heart failure, as well as the parent of its child condition, acute decompensated heart failure. And so this is really what we mean when we talk about the notion of hierarchy. So I mentioned before that conditions in DrugBank really work to sort of glue together a bunch of different data sets. So here we have sort of a brief overview diagram that explains this in some detail. So you can see that conditions are directly used in our data sets concerning things like drug allergy, adverse effects, box warnings, contraindications, and indications. But then also within things like clinical trials, conditions are used to capture the actual disease or condition under study in the trial itself. And then in our most recent dataset edition, which is for rare disease, which we talked about in the previous info session, the conditions help to model the diseases themselves that have actually received an FDA orphan drug designation. And then of course, this also ties to drugs. And then finally, through things like the external mappings, it's possible to connect DrugBank conditions data set to other external sources. And this allows you to do lots of other things, such as getting a sense of demographics if you have information on prevalence or disease burden. So to make this a little bit more concrete, I have just a few quick queries that I'd like to show. So I just need to quickly switch from the slide deck to something else here. Okay, let's see. Okay, so I'll make this just a little bit bigger. Okay. So what we have here is a version of our export data that we offer to individuals with licenses. And I just have a couple of really quick queries that will hopefully show off the conditions data set and also how some of these connections are very valuable. So the first query here is very simple. It's just literally looking at the main conditions data set table. So we can see that each entry has its own DBCOND ID, which is proprietary to DrugBank. And then there's a title for it. Where possible, there's the mappings to MEDRA, ICD-10, and SNOMED. And then here, this is an interesting column here. So this is the preferred term ID, and this is how we capture that notion of synonyms. So in this case, tylerioasis is its own preferred term, but in some cases, for conditions that are synonyms of a more preferred term condition, this value will be different from its ID, and this refers to the row that should actually be preferred in terms of presentation. So now we're going to get into some more interesting queries, because that's basically just looking at the table itself. So in terms of drug allergy, you may want to understand which of a possible list of medications the patient is on could be responsible for a given allergic reaction. So here we can see that within DrugBank, there are 800 drugs that are currently known to present in the very debilitating skin condition, which, depending on severity, is either known as Stevens-Johnson syndrome or toxic epidermal necrolysis. You could look, for example, at the indications. So here we're looking at things that are used to either treat or manage diabetes. And so we can see here that in each case, there'll be at least one drug, but in cases where the indication is for a combination, there'll be one or more additional drugs included as well. So here you can get a sense of what's currently available to treat certain conditions using that conditions data set. And then finally, as I mentioned before, clinical trials are also another area of DrugBank to which we tie conditions. And so here we're actually going by ICD-10 code, which is another way that you can use this data set. And we're looking for anything that's related to the ICD-10 code for breast cancer. So we can see a number of clinical trials. It's actually about 9,100 or so. And then in each case, we have the trial ID, the actual condition, which will be either breast cancer or some more specific form of breast cancer. And then, of course, the drug and some more information about the trial. So this is really just a very brief overview. Of course, there's a lot more that you can do with it, but hopefully this helps you to understand what we mean when we say that the conditions themselves are used in a lot of different data sets within DrugBank. Okay, so I'm just going to switch back to the slide deck very quickly. Okay, perfect. So yeah, so I hope that was helpful. I'm now going to pass things over to Fiza for the remainder of the presentation, and then we'll do hopefully some Q&A at the end.
Great, thanks so much for that, Chris. So the other thing that we wanted to take some time to touch on today was, as I was saying, the difference between a database versus a knowledge base. Since, as I was saying, it is a large misconception and there's a bit of confusion around there. People think the two terms are interchangeable. And on our side here on the sales team, we get asked to compare ourselves to many of the products out there. In fact, there's hundreds of them. There's hundreds of different providers, and actually, I feel like there's probably a new one that we hear about every week. In fact, so if we go on to the next slide, this is a really nice visual that kind of provides a side-by-side comparison. So it's no secret that people in healthcare and biopharma have thousands of different products to help them evaluate the marketplace and help them with their data needs. I'm sure you can all relate to, going on a company website and looking at a product and thinking, so, what does that product actually do? What does that data actually give me? It's not easy to compare apples to apples between all the various different offerings that are out there, especially when it comes to data and data providers. One of the most common questions that we get on the sales team, in fact, is, how is DrugBank different from insert open source? So this chart contains a few examples of major advantages to using a knowledge base such as DrugBank versus a database. It doesn't cover all the differences, but some key points that I want to highlight and I want everyone to take away are that knowledge bases, for example, have relational information that's really, really comprehensive. So we're talking about things like ontologies, logic, rules, and semantic relationships. They are much more robust, therefore, than databases because they build insights, right? As opposed to just having pieces of information like a database would, and even provide new and helpful crosswalks of information. So I guess the way to think about it would be, whereas a database is useful for storing information, knowledge bases are actually more useful for taking that information and using it to store insights and facilitating reasoning based on those insights. So therefore, knowledge bases are useful to apply to many different approaches and applications. We're talking mathematical and statistical analysis and modeling. They're very useful for ML and AI purposes. And that's actually a key way that we support a lot of our customers that are doing early stage drug discovery, for example. So this is a really neat visual that represents the differences between data, information, and knowledge. And a lot of people that we talk to underestimate how much time they're actually taking to clean up data and build relationships between specific pieces of information. There's no lack of data out there, but it's about getting the insights from the data and figuring out why that information matters. For example, according to a report by Anaconda, about 38% of data scientists' time is actually dedicated to just the data cleanup process. So, we're talking a lot of time that's being used to not only source that data, but also to clean it up, to curate it, to standardize it, to structure it, to validate it, and so on. And in fact, most companies aren't able to track this time very well and don't really understand what it costs them per project, per month, or per year. So the other thing that can really differentiate a good knowledge base is how their curation and validation process works. So here at DrugBank, our goal is to make data usable. That's what we're about. So we take an AI with human in the loop approach. We have some very sophisticated proprietary AI and ML that helps us to extract data from hundreds of different sources that are out there. But crucially, we also have an in-house team of domain experts with various different backgrounds. We're talking PhDs, pharmacists, doctors, people with experience in the clinical space, and so on. And this team actually helps us to normalize that data. They do things like compare pieces of conflicting evidence and come up with a source of ground truth. And they even author their own content. And this approach allows us to offer daily updates to all of our customers and provide the most robust data that we can. So I'm going to touch on licensing. I'm going to give you a little bit of information about accessing DrugBank. I'm not going to go into too much detail here. We're more than happy to connect with folks offline if they have any specific questions related to getting DrugBank access for their organization. But there's a couple of things to highlight here. So all of our data sets come in a number of different formats. We have, for example, CSV, JSON, XML, a couple of dialects of SQL as well. And we also do offer a clinical API, and that's really great for plugging into different healthcare software applications that you may have built, typically to help things like decision support. So DrugBank licenses are typically annual recurring licenses. We do have different packages based on the stage of the company, and that really helps us to ensure that we are working with our customers. We have customers that run the gamut between very early stage startups right through to global enterprises, and we want to make sure that we are supporting your growth and growing with you. So in order to do that, we work really hard to make sure that we offer tailored options as much as we can to our customers. For example, we offer multi-year contracts if that's something that you want to talk about. We do also feel very strongly about making sure that our customers are getting access to the most up-to-date information. We don't therefore price based on things like, number of downloads or frequency of downloads. Smaller licenses, smaller contracts, deserve up-to-date information as much as larger ones. So let's talk a little bit about when it might be a time for you to start looking at a DrugBank license, and when you might think that you could be ready for one, ready for making that investment. So to help you make the right decision for your business, we have some information here about when you might want to invest in a DrugBank license and how you can actually maximize the return on that investment as well. So as I was saying, we have a lot of startups that will come to us inquiring about DrugBank licenses, and we want to make sure that we provide guidance on some of the key indicators of when it might be a good idea to look at a provider as opposed to using open sources, for example. So the couple of ones that I wanted to touch on there is proof of concept. So if you're a very early stage company, that's fine. But typically, if you are at the proof of concept stage, it's not the best time to be investing. If you're past the proof of concept stage, then it's a better time. Similarly, if you have at least kind of seed funding or you're generating revenue, that's probably a good time to start thinking about investing in making the data a bit more accessible. Another really important one here is that you have technical people in-house to be able to use the data, manipulate the data via the different formats, use the API and so on. And then I guess once you're starting to realize that the manual data cleanup and curation is taking too long, and that's actually costing you money to use the open data, then that's another good time as well to think about talking to somebody at DrugBank and maybe thinking about a license. Okay, and on that note, this slide just gives you a little bit of an idea as to the types of customers that we currently work with and support. You can see here that we've got a number of different organizations that we work with based on things like size, stage, the type of work that they're doing, and so on. So that just gives you a bit of a flavor. And on that note, I want to thank you all again for your time. We really appreciate your interest in learning more about our data and taking time out of your busy schedules to join us today. I think we can now go ahead and address any questions that people have. If you've not yet added one to the chat, feel free to add a question in there. As I say, if we don't have time to get to any questions today, we can always follow up with individuals offline as well. And if you want to reach out to us directly, our email address is info@drugbank.com, just there. So I'm just going to take a look at the chat and see if we have any questions from anyone. Okay, looks like we don't have anything in the chat over here, Chris.
Yeah, that's fine. Of course, as Krista mentioned, feel free to reach out either through this info email, or alternatively have contact forms on our website. So you can always reach out to us through those as well. So with that, I think we'll wrap up. And yeah, once again, thank you for your time, and hope to see some of you again at a future info session.
Thanks, guys. Take care. Bye-bye.